Hello, welcome to today's statistics video where we're taking a look at tree diagrams, or more specifically, doing a recap on tree diagrams because I'm expecting that a lot of you have in fact already come across them before. But with that said, I am still going to be trying to include enough explanation so that those of you who haven't come across them at all ever before still can get to grips with what they are. And for those of you who have seen them before, I'm going to be including details that you might want to be watching out for. Details such as when are they useful, because often students do very quickly get their head around what a tree diagram is and how they can be used, but they don't know when to use them. What is the correct scenario? Because there's some scenarios where you can use them, but it's not in your best interest to because it just takes a long time. Or there's situations where they should be used because it makes the question easier if you do, and some students don't see that, and then the question is more difficult for them as a result. So, therefore, when are they useful? Well, tree diagrams are most useful when you've got situations that involve multiple events happening successively. So, therefore, that's quite important because we've got multiple different things happening, and therefore the tree diagram shows a visual way of being able to trace through all the different combinations and work out the probabilities for them. However, from an exam technique point of view, something I would like to point out is if you've got more than 3 events happening, you should consider other methods. Just because if you have 4 events happening one after the other, it starts becoming more of a pain to actually have to try and draw out the tree diagram, and so therefore chances are you are maybe missing something in the wording of the question that might make it easier to do than doing a full-on tree diagram for that situation. In addition to that, tree diagrams are particularly useful for situations where the events have different probabilities to each other. So that's things like, let's say I was rolling a dice, then flipping a coin. The probabilities associated with each of the outcomes from rolling a dice are completely different to the probabilities associated when flipping a coin, and so therefore the tree diagram is very useful for those sort of situations. Whereas admittedly, if you've got a situation where you're just doing the same thing repeatedly and the probabilities are identical each time you do it, well, there's something else in statistics that will help us deal with that. So that's something worth bearing in mind for later. So now we know when tree diagrams are useful, how do we actually draw them? Well, it's easier just to show how to draw them by doing an example, so I'll leave that for a bit later when we actually get into an example. There's one more thing I want to talk about though before we do that, and that is how to deal with the probabilities on the tree diagram itself. You need to be aware that you need to multiply probabilities together on the tree diagram when you're tracing a route through the tree diagram, looking at branches that follow on from each other. One branch connected to then another branch connected to another branch, and tracing that path through the tree diagram. Those are the situations when you multiply. And you're probably already aware of that if you've come across tree diagrams before, but I want to make the connection between this action and the word "and." Because the word "and" in probability means something and something else happening almost sort of at the same time or together if it's one after the other. So therefore you need to be aware that this word "and" has a strong link to this idea of multiplying probabilities together. You also need to be aware that it has a link to the intersection symbol when it comes to set notation, something that's particularly useful when you're thinking about Venn diagrams. Whereas you need to be aware that you need to add the probabilities when you are trying to find the overall probability caused by several different routes through that tree diagram. But then on top of that, please be aware that this is strongly linked to the word "or" when it comes to wordy stuff. You're saying either one thing or another different thing happens. You're saying they both can't happen at the same time as each other, but we're trying to look at what's the overall probability of any of these things happening. Worth mentioning, the word "or" does mean something or something else or both happening, but when it comes to the tree diagram, it's an either-or situation most of the time. This is then linked to the union symbol when we're looking at set notation. So, now we've got all that out of the way, let's look at a quick example. So, we have got a scenario with words, and then we've got to find some probabilities. To give us some room, I'm going to first focus on finding a tree diagram rather than finding the probabilities, and that's something worth noting. A lot of the time, questions in A-level won't mention or tell you directly you must draw the tree diagram out. They'll just give you a scenario and you need to realize, oh, wouldn't a tree diagram be useful for this situation? And then you're just choosing to do it so you can use it as a tool to solve the question. So therefore, we are going to begin by focusing on that aspect of this stuff. So you start from a particular place on the far left, and you start having some branches coming out from that place. Each of those branches represents each of the options you have initially, because initially we've got 3 different colors of tickets that we're taking out of this raffle hat, and therefore those are the 3 options we have. We're either going to select a red ticket, a yellow ticket, or a blue ticket, and those are the only options. So what you do is you label the outcomes at the end of each of these branches, and then along the branches themselves on the tree diagram is where you place the probabilities associated with selecting each of those options. For the red tickets, there are 3 red tickets out of a total of 3 plus 1 plus 6, which is 10. So these are probabilities that are going to be out of 10, so therefore the probability of getting a red ticket is 3 out of 10, the probability of getting a yellow ticket is 1 option out of 10, and then the probability of getting a blue ticket is 6 out of 10, which of course you could choose to simplify to 3/5 if you so wish. But then that's us only having dealt with the first ticket being selected out of the hat. We've then got this second event happening as part of our scenario, which is this idea of the fact we're going to take a second ticket out of the hat. And this, by the way, was the clue that gave me the idea that I knew it was a tree diagram question. The fact we did one thing, in this case taking a ticket out of the hat, and then we're doing another separate thing. It's worth mentioning that the first ticket is not being replaced, and that's important because it means the probabilities for selecting the second ticket is different depending on what ticket was chosen first. So if we'd chosen a red ticket first, well, the options for the second ticket are still going to be either a red ticket, either a yellow ticket, or a blue ticket. Whereas if we've chosen a yellow ticket first, that actually narrows our options because there was only 1 yellow ticket, so if we're not replacing the yellow ticket after selecting it, therefore actually there's only red tickets or blue tickets left to select in our particular hat. And then if we selected a blue ticket first, well, then we still have all 3 options open because there were plenty of blue tickets to choose from. Okay, and the probabilities associated with each of these options, if we've chosen 1 red ticket first, so we're going down this top branch here initially, then looking at this second set of 3 branches, well, the thing is we've already taken 1 red ticket, so there's now only 2 red tickets left to choose from, but there's also not 10 tickets in total in the bag, there's now only 9 tickets left in the bag, so the probability is now 2/9 as our option. For the yellow ticket, it's now 1 out of 9, and for the blue ticket, it's going to be 6 out of 9 because we still have the original number of those tickets. Of course, be aware you could simplify 6/9 to of course, 2/3. Then, if we'd taken 1 yellow ticket first, we've still got this idea of only 9 tickets left, but now there's 3 red tickets out of 9, which could be simplified to 1/3. And, of course, there is 6 out of 9, which again, as we said earlier already, is 2/3 for the number of blue tickets we could take. Now looking at the bottom option, it's the same idea, so I'm going to talk about it less. Just be aware there's now 1 less blue ticket, but we still have 3 red tickets and 1 yellow ticket, so that would be therefore 1/3. We're going to have 1/9, and we're going to have 5/9. Apologies, I've written that quite small. Difficult to fit it all on the screen, and that's, by the way, one of the flaws with tree diagrams. Trying to fit all the information in one place is difficult. My tip to you is draw the tree diagram big so it gives you more room to deal with things. We can now use the tree diagram to calculate the probabilities we need. So the first question is asking us to find the probability that both selected tickets are red. So all you need to do is look at the tree diagram and decide which routes along the branches through the tree diagram are going to give you the scenario you care about. In this case, we want the situation that involves 2 red tickets. So therefore, that's going to be this particular route through the tree diagram over here. We pick the first one as red and then the second one as red as well. Therefore, to solve part A, we're choosing the first ticket as red, which is 3/10, and then we're following on from that branch. We're picking the other branch, which has got red as well, which is 2/9, and we're therefore multiplying them together because we're doing one branch followed by another branch in the tree diagram, following along through a full route. The other way of looking at that is deciding it based on words. We're picking one red ticket and a second red ticket, and because we're saying that word "and" there, or it could be described in that way, that's why it's multiply. So therefore we can now calculate that. If you're doing that by hand, that would be 6/90, but then that does simplify to 1/15. Question A done. On to question B. We're now trying to find the probability that the second ticket is blue. And for this situation, we've got to be careful because there's multiple different routes through the tree diagram that result in this. So the first possible route is involved picking the first one as a red ticket and then the second one as a blue ticket. The next option is to pick the first ticket as a yellow ticket and then the second one as a blue. And then the third option is to pick the first ticket as blue and the second ticket as blue as well. So we've got to find the probability of each of these branches individually happening, and then we're going to combine the probabilities from all three of those different options. So therefore the first option is red and blue, so therefore 3/10 times by 2/3 by following along the options on that branch. That will get us 6 out of 30, which is of course just 1/5. We then have for the second combination, yellow first, followed by blue, which is going to be 1/10 times by 2/3, which of course would simplify to 1/15. And then lastly, we have got the blue followed by a second blue. So therefore we're multiplying because we're doing one branch followed by another. And therefore that would be, quite a nice one actually, it's just 1/3. So that's what the probabilities are for those individual routes through the tree diagram. But then we're saying either we get a red and a blue, or a yellow and a blue, or blue and blue. And it's because I'm using that word "or" to separate those different routes, that's sort of implying that this is a situation where you do add. A lot of you might have realized this anyway, just because you know tree diagrams, but I just thought I'd highlight once again just this link to the words, so when you're dealing with wordy questions, you can sort of unpick just from the words what it is you're meant to be doing with your calculations. So all we've got to do is now calculate that, and that will come to, goodness me, what will that come to? That will come to 9 out of 15, which actually is quite nice because then that's just 3/5. And therefore, now we've done that example, I've shown you everything I wanted to show you, and we are done. So hopefully you found this video useful, and I'll see you in a future video. Goodbye.